Good morning, friends. Myself, Dr. M.H. Annaya. In this video, we are going to work out a problem on the development of the lateral surface of a triangular pyramid when it is resting with one of the slant edges parallel to VP and is cut by a section plane which is normal to VP and inclined at an angle to HP, passing through one of the corners of the pyramid. So let us see the question for today's video. A triangular pyramid of side 30 and axis 60 rests on HP on its base with a slant edge parallel to VP. So a triangular pyramid will have three slant edges OA, OB and OC. One of them, the object has to be placed on HP such that one of these is parallel to VP. So friends, what do? We place the pyramid on HP such that one of the base edges of the solid is perpendicular to VP, that is BC perpendicular to VP, such that OA, one of the slant edges of the three slant edges, OA, OB and OC, is parallel to VP. This OA is the slant edge. I will say here, slant edge is parallel to VP, parallel to VP. And now we obtain the front view to the given height by projecting all these corners A, B and C to the front view. Friends, here the height of the solid is 60 millimeter. So we have to mark that height in the front view. This is the height of the solid and this is how it looks in the top view. In the top view, it is seen as a triangle with the vertex O joined to A, joined to B and joined to C. And this slant edge OA is now parallel to VP. Or the same problem can be stated that one of the base edge is perpendicular to VP. Here BC is the base edge which is normal to VP. So it's a typical problem. And friends, now it is being cut by a section plane. SP is section plane, normal to VP and inclined at 60 degrees to HP and passing through one of the corners of the base. So friends, this section plane is perpendicular to VP or normal to VP and it should be inclined at an angle of 60 degrees to HP and must pass through one of the base corners of the base. Draw the development of the lateral surface of the lower part of the pyramid. So for this part, we need to draw the development of the solid completely. So friends, now let us assume that the solid is not cut by any section plane and hence we are going to have here on the lateral surface three isosceles triangles. Now here you can start from the point or from the edge O dash A dash because O dash A dash is totally removed from the section plane. And here you have to be very careful. By chance if you start from O dash B dash or O dash C dash, you are going to have the development in two pieces which is not permitted for a single block. So friends, what I do now, I will start the development here by obtaining the true length. You know very well friends, any development of any solid is always drawn to a true size or we make use of true dimensions of the edges to obtain the development. Friends, here if you observe the top view, OA is parallel to VP. OA is one of the slant edges. When it is parallel here, the corresponding front view O dash A dash will give you true length. So making use of this true length and base edges, this true length which is 30 millimeter in this case, we have to complete the development of this triangular pyramid. Now friends, what do? We take O dash, the vertex here as O and mark true length which is equal to O dash A dash. And here friends, I told you, you have to commence the development from OA only. So taking O as center, true length as radius, I am going to draw an arc. And on this arc, I am going to step up three straight, that is three dimension like 30, 30 and 30, because it has got three sides, AB, BC and CA. If it is a square pyramid, you have to add one more triangle here. That's all the difference. Now friends, let me start the development from the point A. This becomes B, this is C, again A, because in any of the developments, the first line and the last line should have the same marking, whether it is a pyramid or a prism or a cylinder or a cone, whatever it may be. Friends, let us see where all the section plane is cutting the solid. To start with, it is passing through A, one of the corners of the base. So I am going to mark here a point A and another point A here. And then friends, it is cutting the slant edges O dash B dash and O dash C dash at this point. But O dash A dash, O dash B dash and O dash C dash are not true length. So what is to be done? This point where the section plane is cutting the solid has to be transferred to the true length line, that is O dash A dash, and mark this distance from the base on OB and OC. So from you should take this on OB and this is on OC. And that's all. It is passing through one of the base corners and cutting two slant edges, namely O dash B dash and O dash C dash, which I have marked here. Friends, for all these pyramids, cubes and prisms, whatever the points you have got here have to be joined by straight lines. So friends, I am going to join like this from these two and again from here. And friends, you can find here the complete base of the solid, that is edges AB, BC and CA are to be shown by dark line. So this is AB, next comes BC, after that comes CA. So we have to show all this by dark line, because for all these pyramids, the base will have straight edges. And friends, let us mark where all it is cutting. Let me mark this point here as 1, this is 2, this is 3 and finally 1. So 1 is at point A, so I can take this as point 1. And 2 and 3 are on OBOC. This is 2, 3, the 2 points on the slant edges. And friends, after completing this, you have to see what is the portion that is removed. If you observe the front view, this O dash A dash is removed. So this you have to show by very thin line. In fact, you can even delete. So if you are showing it, you have to show by very thin line just visible to you. And friends, on this OB and OC, the bottom portion 2 to B, 3 to C is existing. So 2 to B and 3 to C are these two edges. And this is how we complete the development of this. And here friends, if you call the lower part of this pyramid as P, this figure will give you development of P, which is the lateral surface of the lower part of the pyramid. And friends, now you have to verify again whether the solution you have got is right or wrong. See, when you cut this solid by the section plane passing through A, what happens? This OA does not exist. So this I am showing by very thin line. And then here on OB and OC, portion below 2B, below 2, below 3 is existing. Below 2 on OB, below 3 on OC is existing. So we have, what are the development we have got here is totally correct. Friends, I hope the presentation was interesting. If you like this video, please share the information about my video and about my YouTube channel link, namely Engineering, Drawing and Machine Design by Dr. MHA without fail. I thank you very much for watching my YouTube video. Have a blessed day.